We'll go ahead and get started with lecture. But lecture and review. So the first one was, what's the difference between apparent magnitude and absolute magnitude of the star? And so check your answers, but I'm going to just go ahead and kind of explain it down here. Apparent magnitude. I'll just put MAG for magnitude. Actually, that's how bright it appears. That's what it looks like. That's what the star looks like. Okay. What star looks like? Star looks like. Okay, and one of the things we talked about is that as that star shines, basically the farther away is, the more dilute the light is. Absolute magnitude, and by the way, the symbol for apparent magnitude is lowercase m. For absolute magnitude, ABS, MAG for absolute magnitude. That actually is placing the star, we said 10 parsecs, that's a distance away. Okay, and then you see how bright it is. Okay, so absolute magnitude. So that's 14. Number 17, give the spectral classes of stars. So, of course, 17 looks like that mnemonic device where you do the O, B, fine, guy or girl, kiss me. Okay, that's the 7 spectral types. And the O is the hottest. Okay, and the M is the coolest. Cool. For 20, how big will our sun become when it basically turns into its next stage, which is a red giant? And did you read it's kind of out past, it's not quite to the Earth, right? Or is it to the Earth?
The book says probably even the Earth.
Probably the Earth will be engulfed, but then not Mars? Is that it?
Mars.
Okay, just out to the Earth.
Or if it's Mercury, Venus, it probably the Earth.
Okay, I've read it different things, different times. So I'm going to say out to the Earth. Cool. For 22. 22 goes like this. Basically, we talked that stars can be born in clusters, and the more massive the star lives its life faster. So more massive, okay, lives its life faster. Faster life. Faster and shorter. Okay, 29. How do we detect a black hole? It's kind of a weird sort of question. But 29, remember there was one figure near the end of lecture where basically you have a live star right here. That's my live star. And we have, I'll put BH for black hole over here. That's my little black hole. Okay, and basically what can happen is if that star is kind of swollen, it can dump on the black hole. And it creates what we call an accretion disk. And that's kind of what my purple circle is around the BH. That's your accretion disk. And we can tell it's there because it heats up because of friction. Okay, so we can never see something come from a black hole, but that's how we tell that they're there.
The book explains it that we see it because it emits X-rays.
Okay, yeah, that's the kind of heating up, and it's the same thing. Yep, that's good. So 10's all the way around. All right. So, just a few things here. Actually, there's 7 slides. I know it seems like a lot, but I did want to kind of introduce you to the idea of a galaxy. Okay. So, of course, you probably have an idea about the idea of a galaxy. Galaxies, though we didn't always know about a galaxy. So the thing about galaxies is they're basically in the universe kind of a disk of stars, usually a disk, that are gravitationally bound to each other. So it wasn't until after 1921 that we understood that our universe is filled with galaxies of stars, kind of families of stars. Up to that point, basically, they would see these kind of fuzzy things. Prior to 1921, they'd see these fuzzy things in the sky, and they just kind of called them nebula. Okay, so here's kind of a historic look at an old telescope. This would be, I guess, the dome. You can kind of see the black tube here. Actually, through this telescope, this sketch was made years ago. This is before we understood what a galaxy is. And actually, this is a galaxy. Okay, it's a spiral galaxy. And this same galaxy, if we were to take a photograph of it, looks like this. It's called actually the Whirlpool Galaxy. So yeah, not bad, right? Okay, so the concept of a galaxy. Now the missing piece is to understand what a galaxy is that basically how far away are galaxies, and they are very far away. Okay, so what a galaxy is kind of an island of stars, and we're going to see that if I were to ask most people on the street, when I say galaxy, a lot of times they'll say Milky Way galaxy, and actually that's our galaxy. Our star is just a member of the Milky Way galaxy. So speaking of Milky Way galaxy, okay, so the Milky Way galaxy might conjure up thoughts of, sometimes on a dark night somebody will say, oh, do you see the Milky Way? And the Milky Way actually is related to seeing the Milky Way galaxy. When you see, and that's coming up in the next slide. So we don't have a good picture of our Milky Way galaxy, but what we think it looks like is a spiral galaxy. And one of the things I want to kind of briefly tell you is that there's kind of different types of galaxies. A spiral galaxy is one type. Our galaxy actually, in the center of it, has a supermassive black hole. You know, we talked about you can get a black hole out of a star that dies. You can also get a black hole in the center of galaxies. How wide is our galaxy? Actually, its diameter, okay, the longest part is about 100,000 light years. It has in the center, I told you there's a supermassive black hole there. And in the center, actually there's a cluster, it's kind of a very busy spot, lots of stars, and that's what we call the nuclear bulge. How thick is it? Well, about 26,000 light years. Okay, it has 4 major spiral arms, and they're named, and the spiral arm that the sun is on is the Orion spiral arm. So, like I said, in the center of the Milky Way galaxy, and actually in the center of most galaxies, is a black hole. Kind of makes the thing work. We think that black holes were important in star formation, etc. So our supermassive black hole, actually, to see it, you need to find the constellation Sagittarius and look in that direction, and that actually, you're looking towards the center of our galaxy. So the region is called Sagittarius A star. Okay, so I mentioned dark skies. Somebody might say, ooh, there's the Big Dipper, and ooh, there's the Milky Way. So actually, the Milky Way will go from horizon to horizon, and it's really kind of subtle. You need really dark skies to see it. But here's a picture of the Milky Way, and it doesn't look this distinct in our eyes, but if you take like a photograph of dark skies, you'll kind of see this sort of stuff right here. This is the Milky Way. Okay. And what you're looking at actually is into the plane of our galaxy. So, you know, we've talked about the plane of the ecliptic plane, you know, as the Earth orbits the sun, it kind of has a piece of paper that it kind of skirts around on. Well, also our star is actually moving around that supermassive black hole in the center of our galaxy too. But as we look out to see the Milky Way, in our nighttime skies, we're kind of looking into kind of the wispy part of the Milky Way. The dark regions, you kind of see these dark lanes down here in the Milky Way. Actually, those are dark nebula. So just like we said, you know, when I put I'll go ahead and put the sun here again. Just like we said, when the Earth goes around the sun, we get to see different nighttime stars, different stars at night. Like if I'm over here, if I'm the Earth, I'm over here, I'm going to see those stars. Okay, if I'm over here, at nighttime I see these stars. Okay, so actually we also get to kind of see different parts of the Milky Way too. All right, so different types of galaxies. Like I said, 1921, that wasn't that long ago. We take it kind of for granted that our universe is actually broken into groups of stars we call galaxies of stars. So we have spiral galaxies. I have some examples here. Now, some galaxies we see what we call edge on, okay, and some galaxies we see what we call face on. Face on would be where you see the spiral arms hitting you over the head. Edge on is kind of like this one. This is the Sombrero galaxy. It's Messier Object 104. And can you see the nuclear bulge in the center? So that's a spiral galaxy. There's a subtle difference between spiral galaxies and barred spiral galaxies. Actually, instead of a regular spiral, they think our galaxy, the Milky Way, actually, its center of stars, that bulge, actually is a bar. So that makes it a barred spiral. So there's a photo of a barred spiral. Okay, elliptical galaxies. Elliptical galaxies they don't have spiral arms. They're more what we say kind of spheroidal, kind of. And then the last one is kind of a catch-all, irregular galaxies. So one of the things what astronomers do is they kind of actually, just like stars live their lives, they're born and they kind of evolve. So actually galaxies actually can evolve. They can interact, you know, but each time you see a galaxy, think that you're seeing like billions of stars. Billions and billions of stars. Okay, so again, the 4 types of galaxies. Now, this actually is trying to show you, kind of highlight what I'm trying to show you. Down here, this is the HST, the Hubble Space Telescope. And just like I've been telling you, the Hubble Space Telescope actually, and it kind of goes from pole to pole, it's orbiting the Earth, taking awesome pictures. So what I'm going to show you here actually was taken near the Big Dipper. What they did with the Hubble Space Telescope kind of early on was take a place in the sky where there wasn't anything. Okay, there wasn't anything there. So here's my slide to show you there's nothing there. So with that awesome telescope that can gather light from far away and condense it so we can see it, actually this is what the Hubble Space Telescope saw when it looked into nothingness. So those aren't distant stars in our own galaxy. Those lights are actually distant galaxies in and of themselves. Is that not cool or what? So just a little bit more. One of the terms some of you might have gotten my review sheet that I emailed yesterday afternoon. One of the things I have on there actually is the Andromeda Galaxy. So one last thing I want to kind of put in perspective. So we aren't going to talk about the structure of the universe this semester, but as it turns out, galaxies are kind of organized. Our closest large galaxy actually is the Andromeda Galaxy. So the Milky Way Galaxy, the Andromeda Galaxy are all part of a group of galaxies we call the local cluster. So here, if you kind of see that bullseye-looking thing, that actually within that bullseye-looking thing are some dots. Those are individual galaxies. So galaxies are clustered together. Our cluster happens to be the local cluster. And then this down here is the Andromeda Galaxy. Okay, and the Andromeda Galaxy is, you can actually see it without binoculars or without a telescope. It's so big. The Andromeda Galaxy, maybe you've heard this, that actually the Andromeda Galaxy and the Milky Way Galaxy is doing this kind of crazy dance, that actually they are going to run into each other. Okay? Now, when I say that, it seems like run into each other, there's going to be a collision, but honestly, the billions of stars that are in each galaxy, they will just kind of scoot past each other. So there are documentaries out there where they kind of show you what is that going to look like when the Andromeda Galaxy and our galaxy come together. That'd be cool. So the Andromeda Galaxy is there. And then actually clusters of galaxies are more organized into what we call superclusters. Here's where in science I wish they would have come up with another name. I'm like, really? You couldn't do that? Okay, so we have clusters of galaxies organized into superclusters of galaxies. So then we're actually getting bigger and bigger, kind of approaching what does the universe look like. And in your notes you can kind of see that it's pretty exciting. So, all right. So that's how far I wanted to get.